consider this train locomotive and the train station that's over here to its right. When talking about the train's motion, we have to refer to a fixed reference point somewhere in this sketch or this diagram, and this fixed reference point acts like the origin on a graph. So let's let the train station be the origin, and let's define positive motion as motion being to the right. So when the train goes to the right, we would say it's undergoing positive motion. Now this is arbitrary. Sometimes it may be more advantageous to define left as positive, but most of the time to the right will be positive motion for us. Now this means that on this diagram left is negative, so we'll indicate this by drawing the x-axis and defining each direction. We'll say that positive is forward for this train toward the station, and backwards is left for this train away from the station. And also we'll define vertical motion just in case any ever occurs. We'll say that up is positive and down is negative. So we've defined horizontal and vertical motion with respect to the train station, and so this train now we might say is to the left of the origin. We always want to include the sign conventions in these square brackets. In honors physics, always define what each direction stands for. So here we've got forward, for example, in the square brackets. That is what positive positive in the x direction is standing for on this diagram. Now let's suppose that the locomotive is at a position 20 meters to the left of the station. We would write that its position, we would write D1 equals 20 meters, and because we have a direction associated with this position, we are going to say that this is a vector value, and we now write this little arrow. Sometimes you'll see it with both sides of the arrow, but I usually write it with just this sort of shape like that. This is the vector symbol over the variable, and this now means position. Even though we're using the letter or the variable d, it stands for position. So the symbol D1 with the vector hat or the vector arrow over it itself has meaning. It tells us that this quantity is a vector, which means that it has magnitude, it has units, and it also has a direction. And the key difference between a vector and a scalar is this direction. So for example, if we were to say that the train is 20 meters from the station, just that, we've given a scalar value, and we might say that that's its distance. However, by indicating the direction, which comes from our axes that we use to define the directions, we've given the position vector and not just its scalar distance.